Welcome to this MagiCAD for Revit ventilation module overview, where we're going to go through a brief summary of our tools. Using the MagiCAD duct command, you can easily design systems within Revit by selecting systems. As you can see here, these are our systems from our template. You can also select your duct series, which are your duct families, and then you can also select your sizes of your ductwork, width and heights. You can also have installation series added to here, and also sizing methods that will be used in conjunction with our calculation tool. What you do have down here is a group of offsets. So this is the top of the duct, center of duct, and bottom of the duct. So these are live offsets. And this will change if I add an installation series. You'll notice that the offsets have changed. I'll just take that off for now. What I do have here is some references, so I can reference the offsets, and I can select this button and they'll slightly change. So what these are saying is the top of top, I can reference anything within my model and it'll match the top of that object to the top of my duct. So for example, click top of top, I'll select this duct here, and now it's referenced that duct. And what I can do is I can start to model this duct like that, and you'll see down here on the section that it's in line with that duct. But what I can do, I can also go back into that menu. I can select this justify to selected object, and now I can say I want to go on top of that duct. So what I do is select that, go back in here, but what I don't want is to put that duct directly on top. And if I put a tolerance of 100, press OK, and then just model over the top of that, you'll see there that I've got a 100mm gap in between there. Like so. The vertical crossing tool helps you with coordination within your model. As you can see, we've got a single crossing and a multiple crossing. The only one I'm going to show you now is the multiple crossing. So you'll get three options of how you want to cross. I'm going to use a smart move, or you can use a 2 points. But what I need to do is select the objects that I want to amend. So as you can see, these ducts and pipes are clashing with this rectangular duct. So I can select them, and then I get to select if I want to go above, below. So I'll select this rectangular duct because now I'm referencing the offset. And then I will get this dialog box. And as you can see, I'll get a preview by using this box. I can also close it, but you'll see on the 3D model and the section as well, it will give me what it's about to do. And then in here, I've got my tolerances. So these is my maximum tolerance, and then I've got my minimum tolerance. So basically what these are, the bottom one is how high these fittings can go to without running into each other. And then you've got the high tolerance, which is how high it can go before these fittings start to cross each other. Okay, so anything between this 4205 and this 2613, I can put in my offsets. I can reset all my offsets if I want. I can change my angles, and you'll see that the models will update when I do this. And I can even go back if needs be, and the tolerances will change. What you'll notice is, in here, you'll notice that that is right on top of that duct, which is not what we want. So what we can do, we have this box here where we can add a tolerance, and then we can then update. And as you can see now, I've got a tolerance of 100mm in between that duct. As well as the vertical crossings, we've also got horizontal crossing, singular and multi. I'm going to show you the multi now. Again, we can use the same crossing methods. So I'm going to select two methods here. And what's nice is I've got two ducts on top of each other here. It will give me a indication of which one I'm selecting with the offsets and diameter and even systems. So what I can do is I've clicked a point there, and then past this steel here I can select again. I will then get the plus, which then I can add in the multiple pipes and ducts. And then I can go up here and press finish. And then what I need to do is select the end of that steel. And now what will happen is it will run through the crossing method. As you can see, it's done the pipework and the ductwork at the same time. I've got my tolerances again. I can swap sides if needs be using these arrows that I can see on the preview as well. But I might have to readjust, so I can readjust the base point there. I'm going to go back to what I had before. I've also got a tolerance as well that I can add in there, and again I can change the angle. And once I press OK, as you can see, that has then created that avoidance or the clash. Another useful tool within MagiCAD is the angle to horizontal tool. This is used for creating branches or creating drops within ductwork. So as you can see, I can click anywhere on this duct and this is where it will create a branch. From this I can select an angle that I want to come off at. So if I select 45 degrees, I can also change my duct size. I get the opportunity to select a insulation type if I want to add that on at the minute, and also to add in a sizing method for calculations later on. I can also add a tolerance in here, so whatever I select and reference my offset now, it'll be 100mm from the duct or whatever reference. So if I click at bottom of, I select this duct, it'll now update the offsets between the ducts. Once I press OK, I then get the opportunity to select which side I want to branch off at. So if I click to the left, it will come off at the left, and the right, it will come off at the right, as so. And as you can see, it's created a branch straight off the duct, and it's rotated the tap around the duct. I can also use this to drop straight down or to a certain offset. So as you can see here, if I press 90 degrees, and then I can select this center of duct to 250, and now what it'll do is once I press OK, it'll create a drop, and I'll just show you in the 3D view. It's dropped down to an offset of 250, which without cutting a section, I've just done that very accurately. The Smart tool is a tool that will help you readjust any offsets that might need readjusting after any ducts have changed. So for example, here in this section, I have got a offset of 100 between these ducts. But what if this duct has changed in height and now it's gone up to 350? I've lost my offset now. So I can use the Smart move. I could either do it in plan view or section view, and I can click on that section, click on there, and I can readjust to any offset, but I want to still go on top of. And as you can see, the tolerance of 100 is already in there, so all I need to do is press OK, and now it's shifted that up, and I can quickly do the rest. And it will remember my tolerance again, and then I can shift these all up so I can maintain my 100mm offset that I set out when I first done the coordination. And then that is the Smart tool. Standard connection tool is an easier way of connecting ducts to branches, mains, etc. You can use it singularly, so if I want to connect this branch into this main and select like that, wherever I've selected, it will create a connection between the two. I got the opportunity to change from T to tap or vice versa. I'll choose a tap in this case, and then I'll get my first and second angles. So as you can see from the plan view, 3D view, and the preview that you have here, I can select different angles to come off at, and it will rotate the fitting around the duct, like so. I press OK, it will then create that connection. But not only that, I can select the end of this duct here, and I can even select the elbow on this one. And as you can see, it will give me the options again, and I can flick through and see which ones I actually want to have on there. So maybe it's this one, and I'll press OK, and as you can see, it's converted that elbow into a T. A new update to this tool is the multiple connection. So what I can do is select all these systems, and then what it'll ask me for is to create a connection. And as you can see from the preview, it's a similar sort of menu, but what it will do is connect each one of these systems up multiple. And again, I can choose which ones I want. So I want to match the existing ones, press OK, and then the system is connected. The next tools I'm going to show you is the device connection and the move and copy branch, and also arrays. So I'm going to use this device connection here, and I've got some air terminals here, and what I can do is I can select these 4 terminals, select the duct that I want them to connect to. Again, I've got the preview where I can see what's happening. I can also change from a T to tap. As you can see, you can do it in the preview. It also does it on the plan view and also in the 3D view if you have one open. I can also select flex on there, and I can also change the size of that flex if needs be. I'm going to go back to tap, and then again, as we've seen, we've got these angles or options, if you like, that you can skip through them and see what suits your design better. So I'm going to go for 0 and 90, press OK, and as you can see, it's connected all them up to the air terminals. If I come out of that, once I've done that, I can go on this move and copy branch. So what this will do is it will copy all that branch with one click, and then I can go to this finish, and now I can just copy that branch onto this main. And as you can see, it does it straight away. I can also mirror this if I wanted to, like so. But obviously we've got a few clashes there. So what the tool also does is if I go to erase branch, I can do the same, and then select that branch that I don't want, select that, and it will just get rid of it with one click. Now I'm going to show you the MagiCAD calculation for ventilation. So as you can see here, we've got 2 systems. This is an early stage design system where we've used nodes added onto the end of each duct that we can allow for a flow and a pressure drop. So these can be used for future use or just for bulk loads early stages. And then we've got more of a stage 4 design at the top with actual grills and an actual fan attached. So the first thing I want to look at is the connection nodes or the early stage design. As you can see, I've got some nodes already on here, and then you can tag them. So how you do that is you go to here and connection node, and then add to end of a duct. And what I can do in here is put a comment what it is, and then put in a flow and a pressure. Press OK on that, and then escape out of that, and then I can then tag that. And as you can see there, I know what I've put on that system. So from then on, I can go to our sizing tool, click sizing, And what I can do here is do it for a branch network, but I've also got our sizing methods that live within our data set. So I'm just going to select this max pressure drop of 1 pressure drop per meter, and then this is used for taps. I can also lock my width and heights if I had rectangular ductwork, and all I need to do is select this system, and you'll be given a simple schematic with levels, types, series, products, but you'll also get lengths and flows, velocities, and sizing method used and pressure drop per meter. You can also change the sizes within this by selecting a duct. You can set insulation on from this, but what is also quite good is if you can highlight in model, this is bi-directional, so I can jump and interrogate any part of my model. I've also got a general results of that. So I could do that for each system, but what I'm going to do now is show you the stage 4. So for the stage 4, I can go on to sizing, and then I'm going to do the same again, got the network and sizing rules, and what I can do, anywhere on this system now, it will size the extract and supply. So what I've got here, again, I've got the fan on there, so I can interrogate the fan, look at the product properties, as you can see, where you're on the graph, and there, I've also got the properties of the fan. And that data is only available in MagiCAD products as of yet. I can also, again, click on the model, and it will jump to the object within the report. So I can interrogate this grill. I can show product properties again. I can also copy this to a clipboard, and I can also print this to PDF. As you can see here, you've got all your project information, systems, you've got your the date, calculation date, which is good for QA, and you've also got your full report there. And to swap between the systems, all I do is use this radial button, and we've got them there. And then again, we've got the general results. I can then click OK, and that will update the model. What we're going to go through now is the balancing calculation, which will get a pressure drop for the system. As you can see, we've got balancing methods here. We can also set warning limits for high pressure drops, so we've set it at 200. The first one is balance to minimum pressure, that'll be your index run. We can also balance to fan pressure and also balance to a pressure defined by a sensor within the model. And we can also put design margins on there. And once we select the system we want to size, this will size everything that's connected to that. As you can see, we've got a fan here. So we've got two systems applying extract on there. And within this report, we'll get down the left hand side the simple schematic with the index run highlighted in green, but we'll also have all the different criteria: flow, K factors, pressure drops, static pressure is even in there, and even series and sizes. As you can see, this is the index run highlighting in green. It will also highlight in green within the model as well. We can flick between these two systems. As you can see, this one is the extract and the end device is the index run on there. We can also produce a PDF of this document by going to print. And as you can see, this report will show you project information, calculation data. It will also produce that report below with all the pressure data details. It'll also give you a good QA of a time of when you've done the report as well. We've also got a general section here where it'll give you all the project information, calculation date, project numbers, etc., and even calculation data. And we've also got the calculated flow and pressure, and also the margins included there. And then we've got our air density and the dynamic viscosity of the air. And if we go back on here, we can also go on the product properties. So we can see where the duty point is within the fan, both sides of supply and extract, and we've even got sound data in there as it's a MagiCAD product. We can press OK and update to the system, and that information will be pushed then into that duct, and then we'll be able to tag it. As well as the balancing calculation, we also offer the pressure drop calculation, which is basically the same without any of the balancing, so you've got the same report, etc. But if we look at the options on here, what we can use is it'll run through the system and give you the index run using the MagiCAD product data, so that's the curve on the actual grills. The other option is to use the pressure drops defined as a parameter. So there's an instance parameter on each grill. I've got a grill selected here, and what you would do is in this MC ducting given DP, you'd put the pressure drop for each grill on there, so you could change each grill if you wanted to. And then we also have this use general pressure drops defined within the settings. So what you can do is the calculation will ignore this information and any information within the product, and it will do the pressure drop between the ducts and fittings, and then you will use this defined pressure drops as bulk pressures, and then that will then be added onto the pressure that has been calculated within these ducts, just to give you a bit of an early stage calc in some cases, or if you want to define each pressure within the grill rather than using the manufacturer's data, so it just gives you a bit more control of what you're actually going to use it for. As well as the sizing and balancing calculation, we do offer a sound calculation, which will calculate the reverberation in the ducts and fittings through the system, and then that will give you a NR level within each space here. And what that is, it won't get rid of an acoustician, but it'll give you a better idea of the noise within the room. And it's not the breakout noise from the fan, it's just, like I said, the reverberation through the ducts and fittings. And to do that, if you do not have a fan on the system, you will need a pressure sensor, which is this, and then a sound octave band that you can add to a length of duct. So where you get them from is this calculation control. So we've got a pressure sensor here, and what you do when you add that, you can add a total pressure or a static pressure and put a set point in there. And then what the sound source is your octave bands here, which you can fill out. But we're not going to do that, we've already got some on here. And then what you do is you go to the sound calculation, and then it'll bring up the balancing options to run through the system, so it puts the pressure through the system. And then I'll select the system, and then it will give you your results of the sound within each space and each part of the duct, like that. And once you press OK, update to model, it'll push that information in there. And then what you do is you go back to the space sound calculation, and then you choose your sources, and then you click each room, like so, press finish, and then what you can do is you can go to the analyze tab, and then you can add your sound level like so. So if I click this on here and then go down to total sound level, press OK, you will then see that it will be updated with this legend to the NR level, and it's calculated that in each room like so. This next tool is a Revit tool. It's the duct colour fill, but it works really well in conjunction with our calculations. So it's a bit of a QA check. As we can see, we can click velocity for our colour scheme, and what it'll do is it'll give a legend to our velocities, and then it will colour with the corresponding velocity in the length of duct, as you can see. So it's a bit of a quick check to check if you've got any branches too high in velocity or any mains. You can set them to what you want to highlight any discrepancies within the velocities.